Hello and welcome everybody, this is LA Rathbone. This is part 3 of the GTK4 / GObject tutorial. And in this part what we're going to go ahead and do is add a signal to our GObject. It's going to be a very useless signal, but it'll be a signal nonetheless. So let's just get right to it. Let's open up our demo widget.c file. Let's go up to the top. You'll notice that we've made some additions. So we've added some new globals that we will utilize for our signals. So we're going to make another enumeration. I've given it the tag of signal types. You don't have to do that. I guess I probably just copied and pasted this from other code where I had done that. You could just as easily delete it, but it's kind of nice to have that tag there. Why don't we just go ahead and add one there for properties too? Why not? Well, let's call it property type so that we don't clash with another namespace or something. Let's be consistent. Alright, so we're going to make a signal type called foobar, and kind of like how you do with the property enumeration, you're going to make one called last signal, because what you're going to go ahead and do is make a array of signals that is as large as your last signal, right? Again, just kind of a convenient thing to do. So we've got that. That's great. Nothing here has changed. We still have our forward declarations for our dispose and finalize functions. Not a problem. Here we have added a GOint, which is just an unsigned integer called timeout to our demo widget struct. You'll see why soon. I mean, this is just the stupidest idea I could come up with to show off how to do signals. This is arbitrary. You know, wouldn't always have a timeout, most likely in your GObject definition itself, but you'll see why. We just kind of need to do that here for this example. All right. Let's skip past this. We're going to have a private internal function called foobar signals source func, but just don't worry about that for now. That'll be, you know, the way that C works. Unless you do forward declaration, you have to work backwards, and so just make a mental note of it, but we'll come back to it. We already covered the getters and setters of our properties last time. We're going to skip that. Nothing has changed. Alright, we're going to skip this as well. Let's go all the way down to our class init function. Here's where we go ahead and set up our signal. Now, if you've utilized GTK or GObject, you'll probably have connected to other signals before. For example, the GTK button has the clicked signal, and you've probably tapped into that, and you've probably created callbacks and dealt with that, right? But we're going to create our own custom signal for this GObject, and what we do is we're going to run, there's multiple ways of doing this, but we're going to run a subroutine called signal new class handler, and what it does is it returns a GOint, and so we're going to just utilize our signals open bracket foobar array entry, which is a GOint that we set up before, and the first parameter that it takes is a string for the detailed name of the signal, so we're going to call it foobar. Okay, you can call it whatever you want, but since we are calling our signal foobar, we might as well call it foobar there in the string as well. They then want a G class type, I believe. Let me double check and make sure that I'm getting my parameters right. Now you'll notice that they have changed the documentation on the GTK website. I don't really like it so far. I'm trying to get used to it, but anyway, there it is. We're stuck with it. So yeah, that's right. It takes a G type. So what we need to go ahead and do is grab the G type from the class type, and we do that with this little macro here called GObject class type, and we just run that on object class. They then want to know what your signal flags are. Typically, you're going to tell it whether you want the signal to run first or run last. Run last is a good default if you're not really sure what to do. You could do run first as well, and you would go like that. Again, watch Christian Hergert's video on GObjects if you want a better explanation as to when you would do first versus last. I'm not going to cover that here. I'm going to use last as a default. Now, the next parameter that they want is a GCallback. Okay. Now, this is a newer, I mean, it's still pretty old now. It's been available since 2.18 of glib, which is at this point ancient history. But as opposed to taking what's called an offset of a struct, which would want like a function pointer basically within a struct. Maybe we'll get into why you would want to utilize that in a later video, but for now, let's not go there. This version of the function wants a standard C GCallback function. Now, what is a GCallback? Well, if you go ahead and click on it, it'll tell you that it is basically just a function that takes, the prototype of it is a function that takes no parameters, returns a void, but that's not really typically what a callback is. It's just a very generic function pointer utilized within GObject, because very few of our callbacks are actually going to take no parameters and return a void. You're going to want to cast that to a GCallback if you're going to insert a C function in there. But we're not going to actually run a C function. All we're going to do is emit the signal. Okay, we're not going to have a function run when that signal is emitted. So basically, we're relying on people to connect to the signal and do things, create their own functions, their own callback functions when the signal is emitted. Okay. Now, there's three parameters that are pretty much useless. Okay. I think they used to matter a long time ago. Now they don't. And so there's an accumulator, a marshaller, and acute data. Not in that order, but there they are there. Just put null, null, null for all three of them. And then here's where some meat and potatoes does come into play. Okay, if you wanted to have your signal callbacks, like basically your signal callback prototype, take other parameters other than the instance itself. So other than, in this case, demo widget and gpointer user data. If you wanted to take anything else between those two, okay, you could then set those up here. But because we don't want to do that, we're not going to take like an integer or a string or something sandwiched between the demo widget and sandwiched between the gpointer user data. We're going to use gtype none, comma 0 to say, look, our return type is none because we're not going to have a return value in our prototype. So basically, they're all going to be the return value of the callback will be void, right? And we're going to take no parameters to our callback except for the default instance and pointer for user data. If you did want to put some things between, you would tell it how many. So let's just say you wanted to do 2, then you put 2 here, and then you would put integer, gtype integer or string or whatever. We're not going to do that. Maybe another time, not this time. Okay. That's what we do to set up a signal called foobar that will allow us to connect to it and to provide a callback that will take, again, I'm repeating myself, but the instance being demo widget and a gpointer user data, right? Don't get confused and think that 0 means it'll take nothing. It will still take the instance and the user data, okay? All right, got it, get it, good. Now, because we have no C function that's being run, and because our widget is pretty boring, we need a way for the signal to be emitted in some fashion. Because I have absolutely no creativity and no imagination, I thought, hey, let's just have our widget emit the signal every 5 seconds. Now, how do we do that? Well, what we go ahead and do is, remember way back at the beginning, actually let me make a mark here. Way back at the beginning when we created our GUINT called timeout, right? So we needed that to exist. We could have made it a global, like say, somewhere up here, but that kind of defeats the purpose of object-oriented programming in C. So we're going to stick it in our demo widget struct. Okay, get it, got it, good. This is initted to 0 by default, not because it's a global structure like I accidentally said in the first video, but because GObject will initialize your struct elements to 0 when it creates a new instance of the GObject, unless you specify otherwise in your init function, which we are not doing. Okay, let's go back to our mark. And I'll probably add an errata about that at some point, because that's been bothering me for a while whenever I think about that. Okay, so let's emit our useless signal. How do we do that? Well, in our init function, we're going to set up a timer for the foobar signal source function to be called every 5 seconds. So that it takes gtimeoutadd takes milliseconds as a GUINT as the parameter, right? So what we go ahead and do is, because gtimeoutadd returns a GUINT, we set up our GUINT already to be self-arrow timeout, right? Self-arrow timeout because we set that up in our struct. Every 5 seconds, run foobar signal source func, and then as our user data, what we're going to go ahead and do is pass self. Now you'll see why in a minute. The reason being is that well, all a gsource func takes is a user data. Now, what we could have done if we were being super de-duper creative is we could have put demo widget, we could have gotten ahead of ourselves and written demo widget star self here and blown away this user data stuff, and then, blow away this line here too, and just expect, because we know that gpointer is a generic void star type, and it'll be essentially promoted silently to this type. But I like to keep the prototypes in line with the documentation, so that when I'm cross-referencing, I know, okay, this is a gsource func because it returns rather a g boolean, and it takes a user data only. So I prefer then to go ahead and set up our cast here, our variable to be self casting our user data to demo widget, which we know it is because that's what we did in our gtimeoutadd function. All right, now it's static because it's internal to this this object file / translation unit. All right, it never needs to be. It's not a public function. It's only private to this file. Yeah, all right. So what we're going to do in this source func, all we're going to do is emit our signal. Now, in order to do that, we're going to use the gSignalEmit function, which takes well, let's look it up. gSignalEmit. Great. It takes a GObject star instance. I believe it actually takes a G pointer that we know is a GObject, but because of the new way the documentation sets things up, it uses GObject introspection to tell us what the parameters are rather than the C headers. So just trust me that you don't need a cast here. The next parameter is a GUINT of the signal ID, which again we're using our signals array, and the foobar GUINT is the one that we are going to emit. And then the last parameter is a gquark. Don't ask me what that is. I've looked it up before. I don't remember. You can pretty much always just pass 0 to that. So just trust me on that one. Okay. Now, a gsource func returns a g boolean, and when you utilize a gsource func, let's see if we can look it up. I have to say source func now, I think. No. Oh, come on. Well, let's find it. Let's go back to gtimeoutadd here. Oh, come on. Oh, because it's not part of GObject, it's part of glib. So with the new documentation system, I have to go all the way back. Alright, bear with me for a moment here. Alrighty. Can I just type source func here? Yeah, man, I hate this new system. Anyway, it returns a G boolean. Now you could write true, you could write false, because as it explains here, You return false if the source should be removed, and you turn true if the source should continue. We want the timer to keep going off every 5 seconds, so we want it to continue. So they set up these macros called gsource continue and gsource remove, because those are a little more intuitive than true and false. So they're just mapped to true and false, but gsource continue makes it clear as to what's happening. So we're going to return gsource continue to have the timer continue to be in the glib main loop. Okay? Now you may wonder, how do you get rid of it? Now you could just close the program, and then as just a function of the fact that all we have is this one widget in a window, it'll die with the whole program. But it's a better practice, I think anyway, it's probably a better practice to put it in our dispose or finalize function. We're going to put it in the finalize function because it is something that you just kill. It's not reference counted. I don't see any possibility of cyclical whatever. So let's just put it in the finalize. We will say if self timeout because it's initialized to 0. So if on the off chance that for whatever reason it was never added, it'll check to make sure that we have an actual GUINT that's not 0. Okay, and then we're going to run gsource remove on that GUINT, which will then remove it from the main loop as we finalize our widget. Okay, so yeah, best practice to do that. For this demo, it probably wouldn't make a difference, but it's a good idea. So I think that's it for this file. Let's go ahead and utilize our signal now. So you connect to it like you would with anything else in GTK. We're just going to be lazy and do it in our activate function here in our main.c file. We're going to connect demo to the foobar signal. The callback that we're going to run is called foobar callback, and we're going to pass null in as the user data because we have no user data that we're going to need to use. Okay, so I keep saying okay today. I don't know why. Anyway, here is our foobar callback. Like I said before, remember when we set it up way back when in the demo widget.c file, we set it up so that it would return a void with the gtype none thing, and we didn't add any parameters beyond the defaults. So what we get is the defaults, which is the first parameter being the instance, which is of type demo widget, which is whatever your object type happens to be, and user data. You okay? Did it again. All right. So all we're going to do in our callback is call gprint demo widget says hello, which will just print a lovely little message to our terminal. That's it. So what we expect to have happen here, right, is that every 5 seconds, demo widget says hello will be printed to the screen as a result of connecting to our useless signal. Okay. So is there anything else we need to do here? I don't think so. Right. We've connected to the signal. Everything should be good to go. Okay, so let's quit. Let's make okay, 2 warnings. This is a lovely useless warning about how in our callback function, right, if I could find it here, yeah, foobar callback, right, it took a demo widget star, it took a user data, but we didn't do anything with them, and so it's saying, you didn't do anything with them. You could just ignore the warnings. What I'm going to go ahead and do is edit our make file, and in our warning flags, I'm going to put W, no unused parameter in there, so that it stops bothering us about that. Let's make clean, make again, and then now everything builds without errors or warnings. Now we could run debug.sh, but let's just run main so that we can just see nothing but what we expect to see, which is our demo widget says hello message every 5 seconds. So let's run it. Window opens fine as per usual. Let's wait. There you go. Demo widget says hello. So if we just keep waiting another few seconds, it'll say it again, and it'll just keep saying that again and again and again. It's only saying that because we connected to the signal and told it to run a callback. So just so happens that all our signal does is just run every 5 seconds. It's kind of like the everything's okay alarm from that Simpsons episode. So that's basically the basics of setting up a signal. You could, again, as you could imagine, if our widget was a little less useless, you could imagine how you could set up signals to do anything you like to do, and you can set up any number of parameters that you'd like to have passed to the callbacks, and you could do things with them. But this gives us a just set of kind of boilerplate code to work with. On a go-forward basis, what we're going to do is kind of throw out what we have here with our stupid foobar Baz button and show how you create something a little more customized. Now that we have the basics of how to craft a GObject for GTK purposes, how to sort of get your boilerplate widget code set up to be able to add things to it, how to create properties, how to create signals, we can then now show how you might actually create something a little more custom. And there's multiple ways of doing that. We can draw our widget from scratch, right, using Cairo and GTK internal functions and GDK. We could just put other widgets. This is kind of like a composite widget where we've just put other widgets together into one thing. That's sort of a pretty popular way of crafting a custom widget. So I don't know exactly how I'll show off how to sort of go forward with the customization, but I'll put some thought into it for the next episode. And basically, that's where we'll be going next. We'll be looking at increasing the customization and showing how you actually might create something a little more useful from scratch using GTK. So I hope you've enjoyed part 3. I hope you've learned a thing or two. Again, not as much is being tacked on with parts 2 and part 3 with properties and signals, but now we'll probably be adding a little more complexity next time just by virtue of the way things go now that we've done a couple of simple things above and beyond the first episode. Thank you so much for watching. Good night and good luck.